Deduce the canonical equation of motion of Hamilton's principle, variational principle. Now we know that the Hamilton principle is delta I is equal to delta integral t1 to t2 L dt is equal to 0. Also we know that H is equal to sigma j pj qj dot minus L, where H is the Hamiltonian. So delta I is equal to delta t1 to t2 square bracket starts pj qj dot minus H bracket starts qj pj t bracket close square bracket close dt is equal to 0. The equation 1 is sometimes called as the modified Hamiltonian principle. Now let us label the possible path in configuration space with a parameter alpha. We have delta I is equal to d alpha integral t1 to t2 bracket starts del pi upon d alpha qj dot plus pj delta qj dot upon d alpha minus delta h upon pj del pj upon del alpha minus del h upon del qj upon d alpha minus del h upon dt del t upon d alpha bracket close dt is equal to 0. But the time of the travel along the each of the path is same, that is dt upon d alpha is 0. So delta I is equal to d alpha integral t1 to t2 small bracket starts del p upon del alpha del qj dot plus pj del qj dot upon d alpha minus del h upon del qj upon d alpha minus del h upon del pj upon d alpha bracket close dt is equal to 0. Now integral t1 to t2 pj d qj dot upon d alpha dt minus is equal to pj integral square bracket starts qj upon d alpha square bracket close t1 to t2 minus integral t1 to t2 pj dot d qj over del qj upon del alpha dt, which is equal to 0 minus integral t1 to t2 pj dot d qj upon d alpha dt, because del qj upon d alpha is 0 at the end points square bracket close, so which is equal to integral t1 to t2 pj del qj upon d alpha dt. So delta I is equal to d alpha integral t1 to t2 square bracket small bracket start del pj upon d alpha qj dot minus del pj dot del qj upon d alpha minus del h upon del qj on d alpha minus del h upon del pj dpj d alpha bracket close dt is equal to 0. Or delta I is equal to sigma t1 to t2 integral t1 to t2 sigma j bracket starts delta pj qj dot minus pj dot delta qj minus del h upon del qj delta qj minus del h upon del pj delta pj bracket close dt is equal to 0. which is further equal to integral t1 to t2 square bracket starts sigma j bracket starts qj dot minus del h upon del pj bracket close pj minus bracket starts pj dot plus del h upon del qj bracket close delta qj square bracket close dt is equal to 0. Since the pj and qj are the independent of variables, so their variations delta pj and delta qj will be independent of each other. So delta qj minus del h upon del pj is equal to 0. Pj dot minus del h upon del qj is equal to 0, which implies qj dot is equal to del h upon del pj and pj dot is equal to minus del h upon del qj, which are the desired canonical equation of motion.